Next question is, given the objective function y is equal to f of x1, x2 up to xn and constant g of x1, x2 up to xn is equal to 0, the second order condition for extremum is we need to find out. So what is extremum? Either we should get a relative minimum or relative maximum. Okay, now what are the conditions? If H2 which is second ordered bordered principle, if its determinant is less than 0, and similarly H3 if it is also less than 0, so on up to Hn nth ordered bordered principle minor, if all are less than 0, we get a positive definite matrix, and positive definite matrix satisfies the sufficient condition for relative minimum. On the other hand, if the second ordered border principle, that is H2, if the first is greater than 0, if second, that is H3, if its determinant is less than 0, that means if the bordered principle minors determinant alternate their signs from positive to negative, we get a condition of negative definite matrix, and it satisfies the condition for relative maximum. Okay, let us see in the options what we are being given. So we have H2 less than 0, H3 less than 0. So it says it is a maximum. No, it is not maximum. So this option is incorrect. In the second, H2 greater than 0, H3 less than 0. This satisfies the condition for maximum. This is correct. Now C option, H2 less than 0, H3 greater than 0. So I have told you for relative maximum, our second bordered principle minor should be greater than 0. Since it is less than 0, so this does not satisfy any condition whether for the relative maximum or minimum. What about D? H2 less than 0, H3 less than 0. This satisfies the condition for minimum. This is correct. And what about the last option? H2 less than 0, H3 less than 0. It also satisfies the condition for minimum. So this is also correct. So we have B, D and E. But we don't have here. We have only A and D, C and E, B and D, and B and E. Okay, so I guess there is some problem in the question. So here B and D, it is also correct. B and E, it is also correct. Okay, so it seems there is problem in the question.